Hello and welcome everyone to the LabVIEW exercises. Today's video is all about getting started to the LabVIEW programming. So we will discuss about the very basics of the LabVIEW programming environment so that anyone can just jump start to the LabVIEW programming environment easily. These are our today's topics that we will include in our basics of the LabVIEW. So here are the list. So now we will just jump onto our LabVIEW programming environment. So at the very first time you will open your LabVIEW programming environment, this is the window that will pop up in front of you. So I will just maximize this window size. So here is the first window that you have open in front of you. Now there are some different files that you will encounter when you will just get used to of it, but mostly we will just play with the VIs. VI stand for virtual instrument. So we will just open .vi file, but when you will get used to of it, or in another videos we will also see what are the other extensions of LabVIEW files and where and why they are being utilized and used. So I will open a new VI. To open a new VI, I will just go on to file and then press new VI, or its shortcut key is Ctrl+N. So press a new VI and there you will find out we have two windows that are popped up in front of us. So what are those windows? The first one that I am moving right now is just known as front panel. Front panel has a gray background, and with the white background we have a block diagram. Everything that the user interacts with is placed on the front panel. Meanwhile, our algorithm is being built, or the functions that we think that we are being used should be implemented on our block diagram. So let's just open it side by side. I will press Ctrl+T to open it side by side. Although mostly when we are doing programming, we just jump on to either on the front panel or on our block diagram. So if you open just a front panel, how to switch between the front panel and the block diagram? You will just go on to the window and show block diagram. Similarly, you will again on the block diagram, if you have just opened the block diagram, you will go on to the window and just press show front panel, or you can switch by pressing Ctrl+E. That is an easy way. So you will most probably be switching between these two windows all of the time, so that is why I've just tell you at the very first place. So let's just again open those side by side so that it will be more easy for you to see how things works. So here we have our front panel, and in any space of the gray space, if I just right click, here is another menu that is just popped up in front of me. So again I will repeat, anything the user will interact will be here available. So let's just suppose that the user will interact with the numerics. Again, if I click, the user will can be interacted with the thermometer, and similarly the user can go and choose boolean, and you may need some waveform graphs and other things. As you have noticed, whenever I place anything on my front panel, an image is being generated on the block diagram. What does that mean? That means that everything you place on the front panel has an image on the block diagram, upon which you just implement some functions. So how to implement those functions? So to implement those functions, you just right click on your white screen of the block diagram, and you will find out that there is another menu, functions, list of functions that are available on our block diagram. So how to implement those functions? So you can implement those functions by just again going to their respective panels, or you can build your own thinking that where it should be implemented. So let's just start it with the very simple ones. If I just delete out everything, I will drag and select each and everything, and I will just press delete. and you will find out that all the things have been just removed from our block diagram as well. So I will right click again to our front panel and then just go to numeric and place a numeric control. Let's just say this is our a. Right now what I am trying to do is I'll just do a plus b is equals to c. So again I'll choose a numeric control as for b as a variable, and then I will just select the name b. So here we have a and b, and now what I want is I want to show the results, their addition on some another factor which I should be used as an indicator. So again I'll right click, go to numeric, and I'll place indicator. So this indicator will be my c. So as you can see I have two variables and as a and b. Now I want to show the output as their addition on c. So how will I implement this function? I'll just right click on my block diagram and then just go to numeric and add addition function. So in addition function or any other function, what we need is I want to build some connect the wires between them. So how do I connect wires? So I will just connect it out on the one edge and connect the other edge. Notice that if you have the face on the right side, then it means it is a control, and if you have a face or the node terminal on the left side, then it means that it is an indicator right now. So every time I just bring back my cursor near to the terminals, they automatically changes. I will just also tell that how it change. So we have, if I just go to tools, or sorry, I will just go to view, we have a tools palette in here. These are all the tools that are automatically being selected, which means that we have a cursor right now and I can switch and toggle between them, like connect wires, which is automatically being connected. Now if I just bring back to near to the any terminal, it is not changing because we have just disabled the tools. These are the tools that are automatically selected, so we do not want to mess with them. So I'll just turn on its LED so that we do not take any bad decisions or make mess with the program at the very beginning of our journey. So I'll just close this out, and now if I just increase my control like this way or this way and I run my program, this shows me the result as 6. So now I will also use some of the functions that are available as in here, so do we get a used to of our front panel and block diagram. So what are these functions that are available on our front panel? So this is the function that runs the program, and this is the function that continuously runs the program. If we are not using loops, that we will see what are the loops in an when we progress in our this video. So this is just the abort execution, which means that if we are running the VI, then we must also need to stop the VI. So for that purpose I will just press abort execution and our VI will stop, which means that our program is just stopped. So also, what is this function? So let's just say that I want to increase its size of 3. So what I will do, I'll press this function and this will again pop up another menu, and I can increase the size of the numbers. And what I can other to know the thing is I can justify it. What else I can do, I can change its color as well. Let's just say green. So as you can see, the color is changed, and similarly I can increase its size, style. Let's just say it is bold. So I can do whatever I want with this function. And what other things I can do in here on the front panel is align the objects. Let's just suppose that we have two objects in here. Those are placed at the different positions. So if I just click left edges, those are aligned. Similarly, I can just make their vertical gaps equal. I can just make their size minimum and maximum. These are the things that we use when we are doing some sophisticated programming, or we want our front panel to look more appropriate and good. So why I'm telling you this is just to get used to of this front panel and the block diagram. So here we have again on our block diagram, if I just increase this number and I just turn on this bulb which is highlight execution mode, let's just turn on this bulb and I run my program on our block diagram, it shows how the basically program works. It means that it shows the program runs from the left to right. So there are also many other functions that shows some other meanings too, but here it is enough for us to for the very basic things to get just indulge with the front panel and block diagrams. One more thing I would like to add in here is, one thing that we can also do is we can search our controls or indicators from our front panel. Let's just say control. So we have a tab control or other things that will pop up in front of us, and we can just drag and drop them and place them as well. And similarly we can find out some functions in here, such as I want the subtraction function. So subtract function. So here is our subtract function. I can either drop it or find it. If I just press on find, this will just directly bring me to that palette basically. So I can just now drag and drop and place it on anywhere on my block diagram. But note that if I just press on Windows show help context, I can bring my cursor to any node. This also gives me the detailed explanation of what this function is. So this will just tell me that this is the subtract function that computes the difference between the two inputs. So I hope this is just enough for getting started and with the front panel and block diagram interface. Now we will just move on to the next thing. So I will just delete this out from our block diagram, select all and then just press delete. So it will delete out from everything and even from the front panel. So our next topic is data types. So what are the data types in LabVIEW? There are numeric data types, which is usually in the form of orange color boundary, and then there is a boolean data type. Boolean data types means we are just playing with the true false condition, up or down, high or low, which I can just change like this way. And as you can see, we have a boundary of a green color. So can we just indulge directly with the numeric and the boolean? No, we cannot. So let's just try doing it. So if I just directly connect with the numeric with the boolean, I here find out that the run button or the run arrow is just in the form of a broken wire. So why is it? It is also in the form of a broken wire. If I just bring back to the cursor to the broken wire, it shows me that the error is you have connected two terminals of different data types. So it also indicates as well as the beauty of LabVIEW is as soon as we make mistake in our front panel or the block diagram, there is a error generates that tells us that we are making mistake. We must have to remove it or solve it right now, not at the end of the program, now. So either we can just go or press on the run button and we will find out there is a program, there is an error, and if I just double click on it, it will also show me that here is the problem basically. So I'll just delete this out, and now I can just left click on the wire and just delete this out. So why I cannot just connect between these two data types? Either we can just go with the same data types control and indicators. Let's just say this is my control As you can see in here, as I have already repeated, that if the face is just on the right side, then it means it is a control. If the face is on the left side, then it means an indicator. Now I can just connect these two directly and there will be no error. So if I just turn on the boolean and run my program, the boolean is turned on, either like this way, or we can just manipulate the data by using functionality. What does it mean to use the functionality? This means that, let's just suppose that I just delete this out the boolean. Now I want to interact this numeric with this boolean. So how can I do this? I'll just go to my boolean palette and I'll just go to the comparison palette and I'll use a greater function. Why does it use let's just say that if something just goes beyond 80, then this LED should turn on. So to just go to greater than 80, we need the second step, which means that at Y point we need something that shows that it should either it is greater than 80 or not. So I'll just right click and I'll go to numeric, and there I will find out the numeric constants. Although we have other functions, but here just we need is the numeric constant. So I can just place that in here, double click on it, and I can just select 80, connect their terminals and connect the output. So now if I run my program, the boolean is off. Why is it off? Because it says that the numeric control that in here is not greater than 80. So let's just make it bigger than 80 or greater than 80. Now if I run my program, as we can see in here, my boolean is just turned on, which shows that this numeric, that the number is greater than 80. So in the similar way, we can just manipulate with the other data types. So what are the other data types that are available to us in here? So we have string palettes. Let's just say we have this string as well as string indicator. So either again we can just directly connect that with our string indicator, or we must have to think some condition that may satisfy its position. It means that the strings are just basically the text. It means that we are just going with the text. So I can just whatever I just write in the string control, if I run my program, it will be just reflected back onto the indicator. So again, if I just delete this string and remove the broken wire, left click and then just delete. So how can I manipulate the data in this way? So right now I can manipulate the data by using a comparison function, and there I will just go select. So again, this, if the numeric value is greater than 80, then I want to show some output in the form of string. What does that mean? I will just show you how. Just go to the string palette and there we'll find out the string constants. So I'll just press use yes, and then again go to the string palette, or we can just make the copy of the constant by just pressing Ctrl and then left click and then just drag. So that is how you make copies of already placed functions in LabVIEW. So here I'll just double click and press no. So now I can just connect their terminals. So what is this program is basically doing is, if the numeric value is just greater than 80, it will also simulate the boolean and tells to turn on, and also it will convey the message that if the condition is true, then it will just let it pass yes. If the condition is false, then it will let it pass no. So let's just run our program. Now if I run my program, the value is already greater than 81. So it means that our boolean is on and string showing me yes. If I just decrease its value and run my program, it shows no and the boolean is turned off. So these are some very basic data types in LabVIEW. What are the other data types in LabVIEW? We will also see in when we make some advancement in our video, but here I will just show you a few basics of the data types in here. So these are some data types that are shown on my screen right now. Alright, so we will see these application of these data types in our video when we just make some advancement. Right now I'll just delete, or before deleting this out, now our next function or the next topic are the loops. So right now, till now, I was just pressing my run button every time I needed to run my program. What if I need the program to run in a continuous manner without pressing this run button again and again? So for that purpose, I'll just right click on my block diagram and then just go to structures. Here, the structures or any other palette, one thing I want to add in here, I can also pin out the palette, which means that this palette will not lose when I am using any of its function in here. So if you just want to disappear or remove this from the screen, then you can just press close. So that is how it will be removed from our screen. But otherwise, if you just go to structures, then we have two types of loops. Actually there are more, like time sequences as well acts as a structure, but mostly we encounter with for loops and while loops. So what is the for loop? So if I just place for loop, like drag and drop and then just again drag it to the required position, it will including all the items within the loop area, then it means that it is enclosed. So now still, as you can see, it is giving me an error. Why does that means? If I just click on that and then again double click on in here, it shows that there is some problem with the for loop. So what could be the problem in here? Let's just think about it. Yes, you have imagined correctly. How many times this for loop should execute? Basically, the basic difference between the for loop and the while loop is for loop just runs as many times as you decide. So where we have decided that how many times this loop should work. So here at the end position loop count, you will just go and right click and create a constant. So here it is now at least said that this loop should run 0 times, but we do not want it to run 0 times, we want it to run at least 10 times. So again, if I just run my program, I see that there nothing happened. But why? The loop iteration just happened very fast. So what we can do to slow down the loop iterations? We just right click and go to the timing palette. There we have different timing functions. Right now I will just use the wait function. The wait function acts as the delay between the iterations of the loops. So I'll create a constant and here I can add 1000. Here 1000 means 1 second because one digit expressed as a millisecond. So 1000 will be stand for as 1 second. So make sure that you always put all the things within the loop. So now if I run my program, still we cannot see either it is running or not. So how you can check that this program is running and with the each loop iteration, how you can make sure? So to make sure, I will just go and when my cursor just changes to the terminal connection icon, I will just right click and just create an indicator. So this indicator will show me how many times the loop has just iterated when I just run my program. So now if I just run my program, this is showing me 0, 1, 2, 3 with the time difference of 1 second. this will complete its iteration from 0 to 9, because there are 10 iterations that start from 0 to 9. So that is how the for loop works. Now we will replace that with the while loop. Meanwhile, you just have to take care of one thing. If you just click on the for loop and delete, all of the things that are available within that for loop will also be deleted, even your functions that you have just called or all the things. So how to get back all of this? It's easy. Control plus Z and you have got all the things back. So how you can just replace the for loop with the while loop? Either you can just click on the structures and place a while loop, or you can go again Control plus Z, or you can just right click on any of the boundary of the for loop and replace that with the while loop. So now the loop is just changed to while loop. Now you can just even delete this constant, but still there is an error generated with our while loop. Now the condition changes. The while loop acts like whenever the condition is met, then the while loop should stop. This is the functionality of the while loop, that it iterates exclusively and it iterates infinitely unless you just decide when it should stop. So to stop the while loop, we must have to define some condition. So either you can just make from your algorithm, you can set that whenever the value is greater than 80, then the loop should stop. Let's just say this is just connected, and now we can just run our program. So now we can just decrease it until we just go and eventually press 81. Now it is greater than 80, and as you can see, our program has just stopped. Or we can set it the condition otherwise. Let's just remove the broken wires. One other way to remove the broken wire is Control plus P. So that is this way all of the broken wires will be removed automatically. So now we can create another condition in here. The other condition could be just right click and create a control for it. A button will be created on our front panel to stop the VI at when we want it. So again, just run the program. Now if even it is the value is greater than 82 or 81, the loop will not stop because it is not connected with that condition. Now the stop condition depends upon this stop button. So now if I just press stop button, the loop will stop within the time defined, which means that after 1 second the loop will stop. So that is how the loop works. One more thing that I would like to add within this portion of our video, that within while loops we can do many things else. Let's just remove all of the things in here. And now what else I can do is I would like to introduce shift registers in the LabVIEW. So what are the shift registers here? So let's just say that here we have a boolean LED, and I want that to blink every time, like the blink function. So what I will do is I will connect the input of our indicator with the wall of our while loop. Right now it is just showing me an error, which is not very good thing for our running the program. So how to deal with this error? Basically I will create a replace with the shift register. Now the shift register is created, but still the function or the boolean is not satisfied with the condition that it should run. So what I will do is I'll connect the broken wire with the shift register, and now still there is some error. So how to deal with it? Let's just remove the broken wire and then again connect, and still it is not satisfied. So I think we are making a mistake right in here. So what is the mistake? Let's just say I'll go to boolean and I'll use not gate. So now if I just connect that in here and connect the output, it comes the live. It is now all green, which means that we have successfully made the algorithm, which means that now it allows to pass the data between the while loop. So how the data will pass? So if I just turn on the highlight execution mode and run my program, it shows that the condition was true, and the NOT gate, we know the function of the NOT gate is to, if the condition is true, it will turn on the false, if the condition of the false, and then it will turn on the true. So right now what it is doing is the condition passes through the NOT gate and goes to our shift register. The shift register throws it back to on this terminal, and then the terminal will pass the previous condition in here. So that is how a shift register is worked. Shift registers are also very important to build some arrays, to do some other things like getting average and making PID control and many other things. So let's just stop the highlight execution, and now you can see our LED is blinking with the time difference of 1 second. So that is how we use loops in LabVIEW. So now I will just delete out all the things from our front panel. Alright, so now we will just move on to our next step of basics of LabVIEW programming environment, and the next step is our case structures and enums. So what are the case structures? Usually in other programming environments we use if-else conditions, like if this happens then this should turn on or off, else this should occur, else this should occur. So here we have case structures. So let's just see where are the case structures. So of course from the name it defines that it should be within structures. So here we go on to the structures. Here we have a case structure. So here are our case structures. So how does it work? So basically it works when something comes true or false. So let's just say I can use again thermometer in here, and I can just say that if the thermometer values goes greater than something, let's just say I'll choose greater than 30. For that purpose I will create a constant, and let's just say 30. Then the condition will be true or false will be connected in here, and the output result will give me a string indicator or something else. So what is the output that we want? So as an output, let's just say I want the string indicator again in here like this way. So I will just keep the string indicator outside of the case structure, because in case structure we just implement the condition that we want. So now the basic point is thermometer is just showing us as an indicator. So can we use that as an indicator? No, we cannot. If I just try using that, let's just try connect that in here. It is the broken wire, because we cannot connect the indicator with the greater than function, because it will not occur as a variable. So what we need, we will press Ctrl plus Z and then right click on our indicator in here, and here we have another list, and we can just change it to control. So now it will act as a control. So now I can just connect that like this way. So now we have a condition that will show that either it is a true or false. In case of true, let's just say that I will create a constant and put that inside of the case structure. So now again it is showing me that there is some error, because you just have to fill out the condition of true and false in every scenario. Scenario means it is true. Our condition has defined that this constant, which is shows that the temperature is greater than 30. All right. So again, in the false condition, what you can do is you can again create a constant which will show me the temperature is less than 30. So that's how it will work. So again, what we need is we will place a while loop around it that we have seen a few moments earlier, create a control, and also place a wait timing delay so that the loop will not iterate too much fast, so that this will not create a bogus or do not use excessive memory of our computer. So now if I just run my program, this is working right now. The temperature is less than 30, and if I goes greater than 30, this shows that the temperature is greater than 30. So this is right now just using if and else. So what if I want my case structure to act like the sub diagrams like 1, 2, 3, and 4? So we can just use that as well. So to use that in that way, we need another function. So how we can just use that for 1, 2, 3? So we can use a select function. So let's just say that as select function, I just give the output of my greater than function to our select function in here. And now we have again two conditions, a true or false. In the case of true, let's just decide that if this value is greater than 30, then the constant, create a constant as 1. Otherwise, in the case of false, I will say that in the case of false it is 0. Now our next thing is, if the value goes greater than, if this value goes greater than 60, then what will happen? Now again we will use a case selector. I will make more space clear by just, we can just make the more space clear by pressing this cleanup diagram. So now the space is more clean automatically, like it is automatically cleaned and placed at the appropriate places. So now in this condition, if this is false, then it is connected that in here. If it is greater than this will be the true function. So in the case of true, we have create a constant 2. So alright, now we can just connect our output with that in here. I can just place that in here, and as an output I will just connect that in here. So now it just shows me that we have 0. Now it is showing me that there is 0 and 1 case structure, but we should have 3 case structures right now. Again, I will just press the cleanup diagram so that it will be more clearly visible to us. So now it is showing me that we have 0 and 1 case structure, although we have just decided that there should be 3 case structures, 0, 1, and 2, because if it is greater than 60, and then the case structure will be 2. So we will just go on to 0, then 1, and right click on the space, and then I can add a case after or before, or I can duplicate the case, or I can delete this case. So in this case I will just add the case so that it will create the case number 2. So now again the problem is here that we have not created the every scenario, fulfilling the not scenario. This case structure is just empty, and this trend demands that there should be some output or the control or anything in within this case structure. So again I'll just create a constant which will say that the temperature is greater than 60. So now if I just go on to my block diagram front panel and run my program, it is showing that the temperature is greater than 30. And if it goes greater than 60, now it is showing that the temperature is greater than 60, greater than 30, and the temperature is less than 30. Similarly, we can just control our LEDs by using this case structure, single case structure as well. Alright, so now we can use the case structure in another way. So how we can use the case structures in another way? Let's just say again I will just place this time delay function to a side and delete all of the other things. Let's just say that I'll just delete this out, as well as the string indicator and the string constant within that function as well, or I can just keep that actually just to show you that everything that will be placed within this case structure can be manipulated. So I will just clean up the wire which will just automatically adjust the wire to its best position. So now these are the case structures in here available. So now I'm gonna use enum function. Enumerated function is basically used when we are dealing with usually with the case structures, multiple case structures or nested case structures, which is just also named as state machines in LabVIEW. So here we can just add the functions, like if I just go on to its properties, there I will find out edit items. The first one I can add, let's just say we'll add the multiple functions in here as an add, subtract, and let's just say the third one is multiply, and the fourth one is in here as, and at the fourth one we have we just have to delete out some function, so our 0 is deleted, and the fourth one should also be deleted, and the third one is divide. So we have here 0 1 2 3, and if I just press OK, we have an enum created, and now I can just attach that in here. So now if I just attach that, our case structure automatically changes its names within the headings as subtract function, add function, multiply, subtract, add. Still we are seeing that there is one thing missing. What is that? So if we just see it closely, we find out that there is multiply, subtract and add function, but still we are missing one function, which is the division function. So anywhere even after the subtract, if I just add a case after, it will automatically find out there is a divide function. So here we have again there is a problem that we just have that we need to fulfill each and every case of our case structure. So in one case structure is just missing the link, then it will show an error to us and we cannot run our program. So again, if I just create a constant or use default if unwired, then it will just let me run the program. So here I will just also write the name of the case structures that are available in here. So if I just write down exactly, I'll just multiply, as well as if I just move on in here, I can use subtract, and lastly now we want to just add functions in here, which means that we can add more functionality by implementing some functions on two controls and getting the results on an indicator. So how we will do that? So here we have a numeric 2 control, a numeric control, and in the respective case structure I will add the respective function. Go to numeric and I can add subtract function in here, and then in divide I can just bring the respective function that as I said earlier, and then in the end we have a multiply function. So here we have, and now I can just connect them one by one. So I can just connect it from the either way, but just we need is the connections. So again we are just saying one thing, that the subtract functions containing the bad terminal as well as our case structure contains the empty cases. Empty cases means we have an empty output that we need to fulfill. So here is what we have: divide function as well as here, and then it is just divided. And now in the end we have the last one is our addition, and now it will just allow me to run the program. So now if I run my program in here, it is just saying me that now the two numbers numeric 1 and numeric 2 are being multiplied. So 3 cross 2 is equals to 6. So now I can in the real time I can change their functionality up to subtract. So now it is showing me that 2 minus 3 is equals to minus 1, and if I just increase the number, that acts accordingly. So now I can just add. So 5 plus 3 is equals to 8, and similarly I can just go on to divide, and it is showing me that 5 divided by 3 is equals to 1.66667. So that's how case structures basically works in LabVIEW. So what are the other structures are also available, like for example the flat sequence that allows you to work your program or code in a sequence, the formula node that works on the basis of the conventional wording typing. If you are just very fond of or very used to of the conventional programming and you must have to use LabVIEW, then you use formula nodes and the event structures. All of these things we will see when in my YouTube channel, where I have implemented many programs, so you can just see the use of them or you can just explore it myself. But this was for the basics. So here are the working of case structures. So that was enough for the case structure. Now we will just move on to our next topic, which is all about the arrays. So what are the arrays? So I will just delete this out, all the things from here, also the string indicator, but I will just keep the stop function, otherwise that will give me an error. So here we have, again come back to our front panel, and now what are the arrays? Basically arrays are nonetheless just act as the matrices that we usually use to of things that we get interact with in the MATLAB. So how do the array are being generated? So let's just go to data containers, place an array, and it is an empty array. We can just make an array of controls like numerics. So it means that all the elements in here are numeric. We can just select them 1, 2, 3 or whatsoever, and this is just a numeric array. Or we can again go to data container, or we can just go to boolean and place an LED and then drag and drop, and there we will have only our the boolean array. So this will be our boolean array like this way, and similarly we can again go to and create string array as well if we need it. So what are the arrays? Arrays are basically the elements, the combination of elements of the same data types. You cannot just mix up two data types within the same array. This is the property of the cluster that we will see afterwards, that how the cluster works. So here we have an array. So one easy way to create an array is, if I just delete this out in here, if we run our for loop, let's just say I want to create an array of first 10 numbers or 100 numbers. Now I will just open up my LabVIEW only, and I will just shift from LabVIEW from the block diagram to front panel by using Ctrl+E. I can just create the array of first let's just say 100 numbers. So in order to create that, I will use a for loop. So here I have a for loop and I want to create an array of 100 numbers. So I will create a constant, press 100 and 1, because it will just start from the 0, or otherwise you can just press 100 and use incremental function, so that the iteration will start from 0 and it will start from, by adding +1, that will start from 1. So if I just attach the output of the wire with the wall of my for loop, it and create an indicator. Indicator means now this will create an array. So what it is doing basically, it is, there is a function within the LabVIEW programming environment that it automatically creates an auto index tunnel. Auto index tunnel means from 0 to 100 it will collect all of the data points and then just mix up and then show it within that array. So I'll just jump onto my front panel, and if I just elongate it all the way down in here and run the program, I found that it starts from 1 2 3 4 5 6 7 8 9 10 and then just so on up to 100. So we can just get it up to where we just fetch, where we can elongate it or place it somewhere. So if we want to see all the numbers, then we will just go at the boundary of our array and right click on it, and you can go to visible items, and there we will find out the vertical scroll bar. And now you can just see all of the elements in here, and it is up to 100. So what you can else do with the arrays basically, so within the arrays you can just also use array functions. That are a variety of the functions available in here. So you can just find out the array size. Array size means if I just connect it in here and create an indicator, I will instantly find out what is the size of this array. So if I run my program, it shows that the size of this array is 100, since we have just collected the data points of 100 as we have run the for loop of 100. Similarly, we can just go back to an array and array functions, and there I will find out the index array. So the purpose of the index array is I can just get the data point which I want. So let's just say at the number 10th, what is the data point at the number 10th. So I can create an indicator, and there I will find out if I run my program in here. At the number 10th we have the number 11, and similarly we can just change its index, and then we will get the element as well. So instead of creating the number from 0 to 100, if I just delete this out and go to numeric, there is a separate function called the random number generator in LabVIEW. So you can just directly use this number to create from numbers from 0 to whatsoever. Even you can select the boundaries. If you just create a constant in here, you can either select 1000. So you can just connect the output with this wire, and now it will create automatically the random numbers from 0 to 1000. So since we have set our loop iteration as 100, so it means that the size is still 100, but at the position 11th we have 775. Answer is 775. So similarly, there are many more functions in here to use and implement on the arrays. We can sort the arrays, we can build the arrays, we can array subset, we can find out the maximum and minimum. Let's just implement this functionality of maximum and minimum on this array. So I can just connect that in here, and I can instantly find out that what is the maximum value within that. So if I create an indicator and run my program, here is the maximum value between the random number array set is 992, which is the maximum value which is found at the index 12. So this is how the arrays works basically. Similarly, if I want to create an array of 2D array, 2D array means matrix, then what will I have to do? first of all I will just delete this out everything, and now I will just place another for loop around of this while loop. So it means that if I just choose this 10 and choose the outer loop count as 5, then again I'll just connect the output with the outer loop and then create an indicator. Now this will give me a 2D array. So if I just double click on the indicator that has been generated, I can just go to its corner, any corner, and then just drag the array so to create the entries. So now if I run my program, we have in here 5 rows with the 10 columns. So how is that happened? So the outer loop is 5 and the inner loop is 10. So what it is doing is, at the 0 iteration, the inner loop has just iterated for the 10 times. So it just created the 10 elements within the first row. When there was a second iteration of the outer loop, then again the inner loop just ran for the 10 times and created this information at the second row. So that is how we generate 2D arrays, and similarly we can again manipulate those arrays according to our requirement by using these array functions in here that are available to me, and you can clearly see those all the functions in here. So that is how we use arrays in LabVIEW. There are many more functions of arrays that we can implement, but you can find out the arrays application or more exercise on my channel LabVIEW exercises, that I will show the picture of that in here. So now we will talk about some clusters in LabVIEW. So why clusters are being utilized or used in LabVIEW? So let's just suppose that we have a cluster in here in which we can just combine the classes, different classes. Let's just say we have a thermometer in here, we have a boolean in here, which are completely two different data types, but we are placing them within that one cluster. And similarly the string control in here. So we have 3 different data types that we have just placed in within our cluster. So if I just double click on my cluster, there I find out that we have only one indicator available on our block diagram. Why this is being utilized? Sometimes when we are doing some sophisticated work or the VI, we just built and we know that there is a bundle of functions that will be utilized at the different positions again and again. Then we just create a cluster, and now what we can do is we can change it to control, and now I can fetch any of the result. Let's just say I just only want the boolean out of it. So what I will do is I will go to cluster function, and there I will find out unbundle by name. Either we can use unbundle, bundle, or bundle by name, so that gives us the reliability. So here we have the unbundle function. Now I can just elongate it and I will get all the data types that are sent within this cluster. So here we have a boolean, and now I can create an indicator in here. Meanwhile, do not using the other functions for it while using this cluster. So now if I just turn on the boolean and run my program, the only boolean will be affected. Meanwhile, others are not changed or affected during I run my program. So why the clusters are being utilized? The clusters again are utilized at the position if there are different event structures and we want to fetch the data of only one parameter. So we are using this again clusters, or if we have different functionalities or different parameters at one place and we have just designed and we know that it will be utilized at the different positions, so we will just make out one cluster only and utilize accordingly. Alright, so now we will make some more advancement and move further in our basics of LabVIEW. So that was all. Right now, till now we have just saw how to use numeric controls, indicators, and then we saw loops, and then structures, if else condition, and then arrays, and now we have saw how to use clusters, how to build clusters, how we can fetch data from them. If I just create an indicator right here, I will just get a thermometer value right in here. Like in the similar way, we can get all the things in from by using cluster. Now now we will just move on to our next step, which is basically the graphs and charts. So now if I just shift onto our block diagram by pressing Ctrl plus E, I can again delete all the things from here. Now I want to express some data, some output on charts and graphs. So let's again open it side by side so that again it will be more visible and to you clearly you can understand all the things in here. So right click again, and there you just have to find out the graph palette. So here it is. So there are different types of graphs available in here. So we have waveform chart, graph, XY graph, and the other things. So we will just see the basics. So we want to plot some data in the real time, so we will use waveform chart from here. So if I place a waveform chart, as you can see, I can change its size where I want to place it, and then what I want is I basically want to set the data in the real time on this waveform chart. So I will use a while loop in here. Let's just enclose the waveform chart within the while loop, create a control to give it a condition when the while loop should stop, so that we can run our program. Alright, so here we have a stop condition, so to stop the while loop anytime. Now we want to express the data on our waveform chart. Let's just suppose that I am using right now again a random number generator. So I'll place the random number generator. Within the random number generator, you can use the different data types. Within the numeric data types, we have unsigned 64-bit data, integer 64, and DBL. Those are the things that can change the number, like either it could be in the form of decimal positions, or either it could be just an integer like 1 2 3 4. So these are the types that you will just come to know when you will explore more in LabVIEW, and when you will get used to of LabVIEW programming, when you demand something or need something. So here we have again the upper limit is just 100, and if we do not create the lower limit, then it is obvious that the lower limit is 0. Even if we do not create the upper limit, it is obvious that it is 100. So now I will just attach the output with my waveform chart right now, and also I will place a wait millisecond function. I'll create a constant, and here again I'll give it a 1000, so that it will means that the loop will iterate every 1 second. So now if I run my program here, as you can see that the values are being randomly being generated. It is going up, down, and like this way. So that is how the waveform charts basically works. Now we can also play with its properties. If I just go into the black space of the chart, I can right click and go on to its properties. We can just change the width of the line. So if I just press, as I increase its width, you can see the results on the back end of the window. So let's just suppose I select this, and I can also select the data point at basically it changes. So if I just press this, I can select the point style. I can even change the color of the line. Let's just suppose this one, and also I can change the color of the points so that it will be more clearly visible to us. And like in the similar way, I can change the background of our waveform chart. Let's just suppose that instead of this instead of the black background, what I want is I want to change it to white background. So I will use a tools palette in here, and I will just automatically turn off the automatic tool selection, and there I will select let's just say this white background and click on it. So it means that the white background is selected with a red boundary. So if you observe closely, the boundary of this waveform chart is red, and while the background of the waveform chart is white right now. So that is how you can even play with the waveform charts property. Even if you can make it transparent, if you go on to the transparent, you click it and you just press it. So now it is not transparent right now. The upper skin of the waveform chart turned red. So for that purpose, we just have to go again to the transparent palette, and now if I just click, the boundary of the waveform chart just goes transparent. So that's how you can manipulate different things. So now I will turn on the automatic tool selection, and I will close my the tool palette. So again, if I just run my program, it will keep on updating the points this way, and we can also observe its the previous values. Let's just decrease the delay function so that it will create some more points in less time window. So that is how it is creating data right now, since the live loop iteration is 10 milliseconds. So now I can stop my program, and what if I want to see the previous data? I can just right click on my waveform chart, go to visible items, and there I will find out the X scroll bar. So what will the X scroll bar give me? It will give me all the history of the waveform chart that has been displayed. So like in the similar way, we have another functions like scale legend, graph palette, and all the things that we can use in some other videos, or that you will use when you will doing some sophisticated programming. So now I will just move this waveform chart a little bit aside, make its size a little bit shorter, and now I will just go on to the waveform graph. So what is the basic difference between the graphs? So I will show the difference of the graphs by just going in here, and let's just try to connect the output with the waveform graph. Now it is giving me an error. So what does that mean? So the basic difference between the graph is you do not set the single element to the graph, which means that you just have to set the set of data to the graph. You cannot, it will not accept a single element, a single numerical value. It will accept the array, basically the set of data. So you will just remove the broken wire by pressing Ctrl plus B. Let's just place this waveform graph outside of the while loop. So now if I just connect it outside of the loop, now what it is doing, it is still giving me an error. What if I just what if I just turn this last value to tunnel mode to indexing, so that now it will create the array basically. So that array will be shown on the waveform graph. So now if I run my program, there is waveform chart is still updating the values, but still I'm not getting any value on the waveform graph. So how do I will get the waveform graph value? If you notice, if I just stop the value, all the data, all that is from the beginning to the end, all the data is just created on the waveform graph. So it means that it accepts the value with the form of the waveform graph. So what are the other graphs as well that are available to us in here? If I just delete the broken wire in here, we can also have an XY graph or express XY graph. The express XY graph gives us the feasibility or reliability, or you can say that easiness, that we can select our x-axis values as well as the y-axis values. Let's just suppose that my x-axis values goes with the loop iteration, meanwhile the y-axis value goes with the random number. So now if I run my program here, as you can observe, it is not showing me, but it is updating something. So there is a little bit toggling that is need to set in here. So if we create a constant, it is saying that it is resetting the waveform graph. So it means that it is not showing us anything because of the reset. So if I turn it false, and now if I run my program, now it is just giving me all of the data within the waveform graph. So now it is updating, like it is collecting all of the data points and then showing it on the XY graph. We can also do that by using the simple XY graph, but the express XY graphs gives us more easiness and ready to use. So there are other functions as well, like 3D graphs, that you can find out a video on my channel to see how the 3D graphs works and the other graphs works as well. So that was a brief introduction to how we can plot the data on XY graph, and I also gave you a brief introduction of how to play with its properties. So that was enough, I think, for the XY graphs and the waveform graphs and charts. So now we will move on to our next step, which is our what else we can do in LabVIEW programming environment. Let's just delete this out. So here in LabVIEW we have different modules and toolkits that we can use according to our requirement. Let's just say that if I right click on our block diagram, if I go on to, let's just go on to the other functions that are available in here. The file IO allows us to write or read different types of files like .csv file or Excel other format files, or the text files or the binary files, and this and do all the things. You will also find out the similar videos for the files in my channel, and this timing function have different timing functions that are available to us to get the date and time and other things. So similarly, we have, if we want to acquire some sensors data and all the things, there are the measurement IO, that is DAC MX. We will just use all of these functions and make a program to acquire some sensors data. And if we have third-party hardware devices, let's just say the device that use serial communication, then we will use some of these protocols like Visa, GPIB and other serial communication protocols. And if we have image processing like this way, so we will use these functions, and we will just have to find out what are our requirements so that we can manipulate or we can implement the functions, and we will just fulfill our requirements within the LabVIEW by using this graphical programming approach. So that is how there are different, many different toolkits that are used for the specific purposes and are designed so that you will use some less time and you will get the maximum output without any difficulty. So that is how you will just find out when you'll explore more. And also you can just go on to my channel and watch my videos. There are many different scenarios that I have explained, many different exercises that I have put it, so that you can just watch out and learn, as well as you can just make some advancement in those exercises and see how they works. So I hope this video will give you a brief introduction and will give you confidence to, let's just get started with a LabVIEW programming environment and build your own programming algorithms in LabVIEW very easily. So that was enough. Thank you so much for your watching this video, and please don't forget to subscribe. Thank you so much.